In this video, we'll learn about sparse matrix. So these are the things that I'm going to discuss. How to represent this in our program. Then how to create this sparse matrix. Instead of this, we will be representing like this. Instead of two-dimensional array, how we represented it as a coordinate list or a three-column method. Then next, I will show how to add two matrices. So we will write on the code here for creation and addition. Then the complete program, I will write the program and show you. The complete program we will look in demo video. Now let us start with representation. In this example sparse matrix, this is of dimension 4 cross 5, that is 4 rows and 5 columns. There are 5 non-zero elements, 1, 2, 3, 4, 5. So this first tuple is about dimension and number of non-zero elements. Then these are all non-zero elements, like the first element is at first row and third column and the element is 7. So first row, third column and the element is 7. So for each element we require three things, that's its row number, column number and the element itself. So I am calling them as I, J and X. So for one single element we need three values. So we can combine these three values and we can define a structure. Let us define a structure called element. Struct element. That element is having I as a row number, J as a column number and integer the value element itself. These are the things that defines a single element in a sparse matrix. So for this we need a array of elements in a sparse matrix. 1, 2, 3, 4, 5. 5 elements are there. So we need an array of elements. As well as we need dimensions, that is M and N and number of non-zero elements. So let us call these dimensions as M cross N and also number of elements. So let us define a, so let us look at again what are the things that we need. We need M, N and number of elements and the list of elements. So let us define a structure for sparse matrix. Struct sparse. This is having M for number of rows, N for number of columns. Let us call it as num for number of non-zero elements. That is this one, number of non-zero elements. Total 5 non-zero elements are there. Then, so these three things are defined here by these three variables. Then rest of the elements we can define as array of these elements. So struct element E. I need an array. So shall I declare it as an array of some size? If I declare an array of some size, then it will be limited. It will be for only those many elements. Then instead of taking as static size array, let us take it as a dynamic size array. So for that, I'll just keep it as a pointer. So E is set of elements, that is a pointer. Then dynamically we will create this array. So that's all. This is the structure for sparse matrix. Sparse matrix, let us read it again. A sparse matrix structure is containing number of rows, number of columns, number of non-zero elements and the array of elements which has to be created dynamically. Now let us see how to use this structure and create a sparse matrix. So I'll remove this and use this space. Now let us look at how to create this sparse matrix. So for that I will write a function. So first let us say that I have a main function and inside main function I have created a sparse matrix object. So struct sparse S. This is one of the sparse matrix. This is one sparse matrix. And like this, if you want more, you can take more sparse matrices. So I have taken just one. So S is a sparse matrix. If you look inside S, what are the things it is having? So S is having M, that is number of rows, N, number of columns, and num, that is number of non-zero elements, and E, that is a pointer which can hold a list of elements. So this is M, N, number of elements, and E is a pointer for list of elements. So this is how I got a structure, an object, let us call it as object. Now I will have a function called create. So let us call a function as create, which will send this structure by reference. Now here I will write down that create function. Void create. This function takes a structure type pointer, so that is sparse matrix type pointer, struct, and let us call this pointer as S only. So this function is having a pointer S which is pointing on this one. So this function can access this structure which actually belongs to main function, that is sparse matrix structure. Now what I am going to do in this create function, I am going to fill all these values, that is number of rows, number of columns, and number of non-zero elements, and I will take all the elements and fill up them. So I will write on the code for all those things. So let us write the very first thing. I want to know how many rows and how many columns are there and how many non-zero elements are there. So let us ask it and take it from keyboard. Printf enter dimensions. Then read dimensions. What are those? M and N. These values I want to read them. So I will be reading them through this S. So I will store the values here. See, I am reading two values. Ampersand S arrow M, S arrow M. Then ampersand S arrow N, S arrow N. So this actually belongs to main function, but this is being filled by this function. So both the values M and N are stored. Now I need to know how many non-zero elements are there. So printf enter number of non-zero elements. So enter number of non-zero. I have just written non-zero. So we want non-zero elements. Now scanf, read the number of non-zero elements and store in this one. So scanf ampersand S arrow num, S arrow num. Let us read it as a caps. Actually this is not a cap symbol, but S caps num. Actually caps symbol means this one. This is caps. But this arrow, instead of using term arrow, I feel comfortable calling it as caps. So S caps num. So reading the number of non-zero elements. Now suppose the values that are filled according to this example, this is 4 number of rows and this is 5 number of columns and this is 5, that is number of non-zero elements. Then what should be the size of this array? I have to create this array dynamically. I should have an array of those structure of size 5. So let us create an array of size 5 elements. So I have to take the objects of elements and make an array of elements. So let us write on the code S caps E assign. I have to create an array of elements of size 5. And this is pointing there. So this is I and J and X. I should have an array of size 5. For creating that, we have to dynamically allocate the memory. For that, we have to use malloc function. But I said that I'll be using new operator of C++. That is easy to write. It will reduce the size of the code. Already we have discussed how to write malloc function. Let us write new. New array of what? Array of elements. Of what size? The size is here, the number of elements. So say S caps num, whatever the number we have taken. So this will create this array of elements. So this is ready. Then I have to fill all these elements one by one. So I can say enter all non-zero elements and I can read all of them one by one. So for that I can use a for loop and read all of them one by one. So let us write the code here. Printf enter all non-zero elements. So printf enter all elements. And these elements each will be having row number, column number and the element itself. So I have to read all three values for each element. So I can use a for loop and read all of them. So for that I may need some variable like say I for running a for loop. So for I assign 0, I is less than number of elements. So this is S caps num and I plus plus. Then inside the for loop, I have to read all the elements. Now already we have understood how a main function can create an object of a sparse matrix and call it for creation. Now same way from main function we call for addition, subtraction, whatever you want to do. So I will remove this main function and I will finish the code for creation. So here we have to read three values. So scanf. See, I have to read three values. So scanf, %id, %id, %id. I have to read all these values, three values. So here I have written just one. Ampersand s caps e of I. So I is starting from 0 to num. So I initially this is 0. Then dot I. Here we have the row number and column number. Dot I. This one. Then ampersand is there. So its address. So at this place value will be written. So the first value enter from the keyboard. If it is 1, then 1 will be written. Then likewise, I have to read other two values also. So there is no space. I'll just write below this one. So s caps e of I dot j ampersand s caps e of I dot x. This is how I can scan all three values. So that's all. This is a create function. Next we will see how to add two sparse matrices. So for that I'll just write the function, the code for adding two sparse matrices using the same representation.